Afternoon. Myself Dr.A.Vaniprabha, Associate Professor, EC Department. Continuation of the previous topics, IEEE Standard. Today's topic is on IEEE Standard 802.15.4. LR. IEEE Standard is a standard specifying the MAC and physical layers for low rate. LR stands for low rate wireless personal area networks. LRWPANs. LRWPAN are used for applications with low data rate requirements such as wireless sensor networks, home automation, and industrial control. This is a low data rate standard. It has low complexity, multi-month to multi-year battery life, peer-to-peer and star topologies. Data rates ranges from 20 kbps at 868 MHz to 250 kbps at 2450 MHz. The major application it supports is sensors, interactive toys, joysticks, and remote controls. Followed by this is LRWPAN device types. This involves different types of devices including full function device FFDs. These devices can operate as coordinators or routers in the network and have more capabilities than reduced function device. Another one is reduced function device RFDs. These devices have limited capabilities and typically act as end devices in the network. Full function device operate in three modes serving as a personal area network coordinator, a coordinator or a device. RFD are intended for applications that are extremely very simple. An FFD can talk to RFDs or other FFDs, while an RFD cannot communicate to an FFD. It can compete with one FFD. FFD performs as PAN coordinator, controls an optional superframe structure, provides beacons for synchronization and optional guaranteed time slots for low latency applications. This is the frame format for FFD working as a PAN coordinator, which consists of a frame beacons with two periods, contention period and contention free period. Device compared for access. It is slotted CSMA-CA protocol and guaranteed time slots GTS. Next is the beacon frames. Beacon frames are periodically transmitted by coordinators in low rate WPANs. They contain information about the network including the PAN ID, the coordinator's address and superframe structure. Beacon frames allow devices to synchronize with the network and join or leave as whenever needed. The low rate WPAN standard allows the optimal use of a superframe structure. The format of the superframe is defined by the coordinator. This superframe is bounded by the network beacons sent by the coordinator and is divided into 16 equally sized slots. The beacon frame is transmitted in the first slot of each superframe. If a coordinator does not wish to use the superframe structure, it may turn off the beacon transmission. The beacons are used to synchronize the attached devices, to identify the PAN and to describe the superframe structure. So next is CSMA-CA operation. CSMA's carrier sense multiple access with collision avoidance is a channel access method used in low rate WPANs as to have a collision-free communication or transmission. Before transmitting data, devices listen to the channel to detect ongoing transmissions. If the channel is clear, the device waits for a random backoff period before attempting to transmit. CSMA-CA helps avoid collisions by reducing the likelihood of multiple devices transmitting simultaneously. Non-beacon enabled networks are used in unslotted CSMA-CA channel access mechanism. Each time a device wishes to transmit data frames or MAC commands, it shall wait for a random off period. If the channel is found idle following the beacon random back of the device shall transmit its data. If the channel is found to be busy following the random back off, the device shall wait for another random period before trying to access the channel again. Acknowledgement frames shall be sent without using a CSMA-CA mechanism. So this frames, time frames, depicts the transmission of slots based on the availability of the channel. Pure Aloha protocol. Shaded frame indicates the collision. So if the frame is traveling or if the packet is moving from one point to another, if already the packets are being transmitted in a single channel, collision occurs. This is the picture that depicts the collision. The shaded block represents the collision. Beacon-enabled networks use a slotted CSMA-CA channel access mechanism where the bake-off slots are aligned with the start of the beacon transmission. So this slotted Aloha protocol also indicates the collision in bidirectional way. So next is differences between Bluetooth versus Zigbee. Bluetooth and Zigbee are both wireless communication standards, but they are different purposes and have different design considerations. Bluetooth is typically used for short-range point-to-point or point-to-multipoint communication with a focus on supporting various applications such as audio streaming, file transfer and device connectivity. Zigbee on the other hand is optimized for low power, low data rate applications in LR, low rate W bands such as home automation, smart meters and industrial control. While Bluetooth provides higher data rates and is suitable for multimedia applications, Zigbee offers low power consumption and is better suited for applications requiring long battery life and simpler communication. The modulation technique is FHSS as followed by Bluetooth, whereas Zigbee DSS. The protocol stack size is 250 kilobytes. Zigbee has 28 kilobytes. Battery Bluetooth intended for frequent recharging. Zigbee and not rechargeable. The battery will last for up to 10 years. The maximum network speed that Bluetooth offers is 1 Mbps. Zigbee offers 250 kbps. The range it covers is 1 or 100 meters depending on radio class. Zigbee covers up to 70 meters. Typical network join time is minimum time of 3 seconds, whereas Zigbee requires 30 milliseconds. Next topic is IEEE 802.15 W band